Hi everybody. This is going to be a short introduction to the periodic table and a quick way to use that table to create Bohr models of your atoms. So right now I want to tell you that I'm working on a website that's called PeriTable.com, and they've got a periodic table that has different tabs, and right now I'm working on the isotope tab here, and it's kind of interesting. It will tell me. Right now I'm looking at boron. Boron has 5 protons and it's got an atomic mass of 10.8. It also tells me down here in this little corner right here that boron has 2 isotopes. And an isotope is a variation of that boron atom that changes the number of neutrons. So if I click on it, it'll actually spit out which variations of boron there are. So boron has a version called boron 10, and a boron that's called boron 11. And all versions of boron are going to have 5 protons. Okay, 5 protons, because that's what defines boron as being boron, is the number of protons. But this version has 11 total objects in the nucleus. So if there's 5 protons, what else is in there? Well, if there's 11 total things, and 5 of them are protons, how many neutrons does that leave? It means we have 6 neutrons. If we flip over here and we say, let's take a look at boron 10, well, if it has 10 total things and 5 of them are protons, how many are left to be neutrons? And that has to be 5. So boron 11 has 6 neutrons, slightly heavier, and boron 10 has only 5 neutrons, so it's slightly lighter. When we look, boron 10 is about 20% of all the total boron that there is, and the remaining 80% is boron 11. So if you were to average 80% 11 and 20% 10, you would wind up with an average that was somewhere around 10.8. Sorry, I keep clicking on stuff. So somewhere around 10.8 would be our average. So our atomic mass is actually the weighted average of all the isotopes. So let's click back on here and then let's talk a little bit about how to make a Bohr model of this. So say we look at boron and we're going to look at boron 10. So boron 10 is going to need 5 protons. So it'll have 5 protons, and it's going to have 5 neutrons, and those are going to be locked in its nucleus. Now I'm drawing a fairly large nucleus here, but let's pretend that it's almost microscopically small, that it's about this big. And then outside there, we're going to need to put our electrons. So if it's got 5 protons, it also needs to have 5 neutrons. And Bohr told us that the first level of electrons can only hold 2. So if it can only hold 2, then I have to add in a second level of electrons, and I need 5 total protons, so this is going to have to be 3 protons here. Now, if you notice, it's in family 13, and family 13, as we talked about before, the 3, the ones place, is going to be an indicator of how many electrons are in the outer level of that atom. Or another way of saying that is, the ones place here will tell us the number of valence electrons. Now that's only true of the representative elements, the ones here and 1 and 2. So that does not include these families in the middle. We're going to skip those. That's our D section that we're going to talk about in our next video. So it's just 1 and 2, 13 through 18 will be able to tell us how many should be in our outer shell. Okay, let's try another example. So let's say we take chlorine. So chlorine actually has 3 isotopes, and let's pick this one, chlorine 17. And let's try and draw a Bohr model for that. So chlorine 37 has 17 protons down here. So its nucleus is going to have 17 protons, and since it's got 37 total things in there, the remaining 20 objects inside that nucleus have to be neutrons. So 17 protons, 20 neutrons. So here's my nucleus. I have to draw in 17 electrons, but only 2 of them are going to fit on my first level. Then I'm going to need 8 for my second level, and my third level is going to have 7 electrons. So if I look, chlorine is in the 17th family up here, and which means it's going to have 7 outside electrons, which it does. So that's a quick way to look at Bohr's model and how to figure out if your Bohr model is correct. Another quick trick is that chlorine is on the 3rd level down, which means that it should have 3 energy levels, 3 levels of electron rings, which it does, and it should have 7 valence electrons, which it does, so we're pretty close there. So I want you to pause the video right now. We're going to erase some stuff here, and I want you to try and do a Bohr model for potassium. And let's pick potassium 41. So how are we going to draw that? Take a second, pause the video, and draw a Bohr model for potassium 41. Okay, so you had a chance to do that. Let me help you out here. So if it's potassium 41, that means it has 41 protons. No, sorry about that. It's got 41 total things in the nucleus. And of those total of 41 things, 19 have to be protons. Okay, so if there are 19 total protons, we have to get to 41 total objects. The remaining things have to be 22 neutrons. So going back to the protons, I'll have my nucleus, and on my first level here, I'm going to shorten it up, I can only put 2. We've got to get to 19. So on my second level, I can have 8. That gives me to 10. And on my third level, I can have 8. That's 18. So I'm going to need a 4th level here. And on the 4th level, I can squeeze 1. So according to my check markers here, I should have 4 levels of electrons. And I'm on the 4th level, so far so good. And my outer layer has 1 electron, and I am in the 1st family, so it all checks out. So go to PeriTable.com. Let me write that up there again, PeriTable.com, and play with its isotopes section there and see what you can do. See if you can do your own Bohr model and see how it comes out. Remember, go back, watch this video again, take notes, and see how things go. Good luck.